Hello guys again. We are back with the GRE quiz with the challenging questions. So we had discussed one of the questions recently in another video. So we'll be continuing with the rest of them. So first one here is the area of this shape, which you can see is a trapezoid. So there are two identical trapezoids. We'll just find the area of one of them and then double it. So this length is from negative a comma a to a comma a. So this negative a to a, right? So a minus minus a. So that's just 2a. We don't need to use the distance formula because it's along the same horizontal line, right? And here negative 2a to 2a. So that's 4a. From here, from x-axis to y equal to a here, right? So that means its height is a unit. So the area is sum of the parallel sides over 2 times the height, and there are two of them. So that's 6a squared, right? In case you're not aware of this formula for the trapezoid, sum of parallel sides over 2 times height, you can just construct a rectangle all around it. Now this rectangle, this length is 4a and this is 2a. So the area is 8a squared minus these triangles. So this gap is a units, this gap is a units. So it's half a squared, 4 of those. So it's 8 minus 2, 6a squared. Either way is fine. Let's go to the next one. So it says that positive integers k and n are each divided by 9. The remainders are 2 and 5. So k divided by 9, the remainder is 2. And n divided by 9, the remainder is 5. So k is a number which is bigger than n. So when they're subtracted, so k minus n divided by 9, the remainder should have been 2 minus 5. That's negative 3. But then when you're dividing by 9 and you get a remainder of negative 3, it basically means that you are 3 short, right, of the divisor. In this case, the divisor being 9. So 3 short of 9. So the actual remainder is 6. Alternatively, we can just pick some numbers. So divided by 9, a remainder 2 could be like, for example, 9 times some quotient. So we can take, let's say, the quotient to be 2 plus 2. So 20. And n can be, let's say, 9 times 1 plus 5. So that's 14. So when you subtract them, you get 6. 6 divided by 9. Obviously, it doesn't divide. 6 itself is the remainder. Let's go to the next one. So here it's saying 4 people consisting of 2 men and 2 women have to be selected from 5 sets of twins, fraternal twins, where each set consists of a man and a woman. So what you have is basically, let's say, A male, A female, then similarly B male, B female, C male, C female, okay? 5 of them, D male and D female. So these are the 5 sets. I specifically need 2 men and 2 women. And only one person from a set of twins can be selected. Means you cannot select both of these A's, okay? You can only select one of them. If only one person from each set of twins may be selected. So how many ways can you form the committee? So when you need 2 men and 2 women, so let us first choose, let's say, 2, like there are 5 categories, right? Basically like 5, what do I call them? 5 twins in that sense, right? So out of those 5, let's pick any 2. So we do 5C2, okay? So let's say we chose this one, A, and let's say B, okay? Then we choose 2 others from the remaining. So let's say we chose C and D. So that means 3 are left. So and 3C2, right? 5C2 and 3C2. Now, when I'm choosing 5C2 and I'm choosing the males from there, let us say, and I'm choosing the 3C2 and I'm choosing the females. Now, you might say that, okay, when I'm choosing 5C2, I have an option of either choosing male or female, right? And therefore, I should multiply with. squared in each case, and again here also 2 squared. But we'll not be doing that because my logic is when I'm saying 5c2, and let us say I could have also chosen, for that matter, the C's and the D's, right? So I'm choosing the male and I'm choosing the female, right? So when I'm choosing the males, let us say I chose 5c2, the A's and the B's, the males from A's and B's. And when I'm choosing the females from the remaining three, I'm choosing the C and the D. But when I'm doing 5c2, there will be a scenario where I chose the C and D male also, right? And when I'm doing the 3c2, then I'm choosing A and B as the females. So that means this 5c2 and 3c2, since we are doing as an ordered selection, first male, then female. So all those scenarios are already covered. So we don't need to consider male and female within this. So like when we do should not be doing 5c2 times 2 squared or something of that sort. Okay. So 5c2 is for the males. Now ignore them. 3c2 is for the females. We are done with the selection. Okay. So 5c2 is 10, 3c2 is 3. So 10 times 3. So that's 30 ways. So that is the fourth option. I hope this is fine. Next. So here they're saying x is a number which is positive. R is 20% greater than x. So let's write that 1.2x. T is 20% less. So it's 0.8. Now they're saying R is p% greater than T. So they're asking R is what percent more than T. So if I do R over T, so I'm going to get 1.2x over 0.8x. So 12 over 8, so that's 1.5. Meaning 150% means R is 50% greater than T. So P's value is 50. So 50 is greater than 40. So quantity A is bigger. That's our answer. Next, PQ is a diameter. Okay, so let us draw it. And line L is tangent to the circle at P. Okay, so let's draw a diagram like this. PQ is the diameter and some line is there which is tangent. So this is actually the diagram. The diagram is missing. I'll just draw the diagram for you. So L is the tangent to the circle at P. M is tangent to the circle at Q. This is M. And N is the tangent to the circle. So N is somewhere here. In the main question, N was somewhere here. And X was this angle, X degree. They have mentioned that X is less than 90 as it's shown here. Okay. So, and as far as I remember, this was R, this was S. Okay. This was RS. So the question was, you have to compare RS and PQ. So right now, if you look at RS and PQ, it is looking almost equal, right? You're not very sure about which one is bigger. And depending on X, how that length would change. So what we do is, one way of solving is, we just tilt this line PQ a little bit more, okay? So let me draw it again. Different versions of the diagram. So let us say PQ is exactly 90 degree like this. PQ is direct straight horizontal like this. This is M. This is L. And this is N. And here X is exactly 90 degree. This is RS. So as you can see, PQ and RS are equal in length. Right? Now as we tilt PQ and RS, it looks as if RS has become longer. But if I, let's say, tilt it a bit more, just to see how it works. Say something like this. Now, this is less than 90 degree, definitely. And here, if I am drawing, now as you can see, RS has become pretty large. PQ in all of these cases is the same diameter. So PQ does not change. As you can see, RS keeps on becoming longer. So RS will always be longer than PQ because we cannot include the case where X is exactly 90 degree. So we can conclude that A is greater than B, right? To look at a proper proof of this, to look at a proper proof, let's say this is the center O. Let's join this one and this one. The proof is quite involved. Okay, so a lot of involvement in proper maths will come in. So as you can see, radius and tangent are perpendicular. So these are all 90 degrees. Okay. Now, this triangle that we have here, ROS. So what sort of a triangle is that? If you look carefully, this is X, obviously, because this triangle and this triangle are going to be congruent. So the remaining angle is 180 minus 2x. So half of that 90 minus x, 90 minus x. So triangle ROS is right angled. As a result, when you have dropped a perpendicular in a right angle triangle, you have created a lot of similar triangles. Okay, let's call it T. So you would have got triangle ROS similar to triangle RTO, similar to triangle OS, OTS. OTS. And using these similarities, what we get is OT squared is equal to RT times ST. Okay, from similar triangles. That's the rule. Also, it implies that OT is the square root of RT times ST. So that means the geometric mean of RT and ST. Now you might know the AMGM inequality. Arithmetic mean is greater than the geometric mean. So we have RT plus ST over 2 is greater than or equal to square root of RT times ST. Now RT plus ST over 2 is nothing but RS by 2. Greater than equal to RT times ST root over is OT, which is the radius. So if I cross multiply, RS is greater than or equal to 2R, which is PQ. So RS is greater than or equal to PQ. The equal to happens when the arithmetic mean and geometric mean are equal, when RT and ST are equal. Now see, RT will be equal to ST only when this is a straight line, like 190 degree, X is 90 degree. Then it would be the midpoint. But then we have already excluded that X is not 90 degree. So RS will always be strictly greater than PQ. So that's the proper proof of this, why it will be so. But obviously this you cannot do on the test, right? Doesn't make sense. So the best alternative is to just draw different versions of this diagram by tilting PQ, because X is the thing that is you can control, right? You can change. So changing X, you can see that whenever X becomes smaller and smaller, RS becomes longer and longer. So that means RS is always greater than PQ. Next. So k is an integer between 1 and 10. So if you divide this, so it's 112 times 10 to the power 4 divided by, so now you have got 6 and this will become 1000. So basically this you have 2 times 10 to the power 7. Now they have said that k is a number between 1 and 10. So obviously the only option is 2, because if I take a 10, it becomes 20. So the value of k is 2, and here that x is 7. So x minus k is 5. So the two quantities are equal. Right? So this was on exponents. Next. Each side of square S has length 2. 5 different points lie inside S. So they are saying the distance between the closest 2 points. And you have to compare root 2. So if I take the square of side length 2, let's call it ABCD. And the distance between the closest 2 points. Now obviously I can pick two closest points very close to each other, right? So definitely the minimum value of this root 2 is bigger. There is no doubt about it. Okay. But I want to check the maximum possible value of this distance between the two closest points. To maximize that, only then I can uniformly comment, right? Like always comment that quantity B is bigger or quantity A is larger. Otherwise, we have to show that quantity A is sometimes larger, quantity B is sometimes larger. So we need to check minimum value. Minimum case is always, it's obviously B is larger. For the maximum case, so we need to pick the 4 points as far away from each other because I need to maximize the gap. Now, where do we put the next point? The fifth point. The point which is farthest from all of them will be, so if I take a point which is farthest from A and C, okay, the farthest from A and C, so it should be in the along the perpendicular bisector of the length AC, right? Because if I have something which is close to just a second. Yeah. So if I have something which is closer to A than to C, then the maximizing distance will not happen, right? And that point will be closer to that. So I want it to be equally distant from A and C. So that must be along this perpendicular line BD. And the point equally distant from B and D will be along the perpendicular line AC. So both of the perpendicular lines meet at this point O. So that would be the position of the fifth point, which is farthest from all of them. Now, if you look at this carefully, 2 and 2, so the diagonal is 2 root 2. So each one will be root 2. So that means the distance between the closest 2 points amongst the 5 is obviously either AO or BO or CO or DO, and that would be root 2. So they are either equal to or this is bigger. So the relationship is not defined. It's less than or equal to. A is less than or equal to B. Okay, let's move on. So in this question, they're basically saying that in the XY plane, you have a line and the 2 points PQ and AB. You have to decide which one is of the two is bigger, P minus B or A minus Q. So one way of looking at this is, if you look at this line and this line, just a minute. Okay, so this is the line and that is the line. So now this line which is there passing through 0, 0 and minus 3, comma 3, the slope of this line is 3 minus 0 over minus 3 minus 0. So slope is negative 1. Now this line, as you can see, is little flat. So that means this line has a slope less than minus 1. So the slope here would be Q minus 0 over P minus 0 is less than minus 1. Whereas this one, which is steeper, okay, so it's greater than minus 1, sorry, because the slope is greater than minus 1. My mistake. Greater than minus 1. Like greater than minus 1 means like minus half and so on, right? It's flat. So the magnitude of the slope will be like half, 1/3 and so on. So with the negative sign, it is now greater than minus 1. For this other line, however, which is steeper, the slope is B minus 0 over Q, A minus 0. This is less than minus 1. Now in this fourth quadrant, P is positive, Q is negative, A is positive, B is negative. So if I cross multiply, A being positive, we can just cross multiply B less than negative A, or in other words, A plus B is negative. Here P is positive, we can cross multiply again, and after cross multiplying we have Q greater than minus P, so P plus Q is positive. So from this we can conclude that P plus Q must be greater than A plus B. Take the B to the left and push the Q to the right. So P minus B is greater than A minus Q. So that is the proper way of solving this. Okay. A faster and simpler way of solving this is just pick some values. So P comma Q, let us say, as we know that the point here on this given line, okay, on the given line, a point here could be, for example, x is 3, y is minus 3, right? Something like that. Because it is exactly 45-degree line, slope is -1, so it has to be x and y values equal in magnitude and opposite in sign, x positive, y negative. Since this point PQ is above it, that means we can pick a x value, let's say 3 only, and the y value we can take to be greater than -3, so like -2. Now, since a comma b is below it, you can take a to be 3 only, but b to be, say, -4, smaller. So we are looking at values of a as 3, b as -4, p as 3 and 3, and q as -2. So p minus b would be 3 minus -4, so that's 7. A minus q would be 3 minus -2, so that's 5. So a is bigger than b. Okay, this is another way of solving, which is much faster. Next, here it's saying there's a plus sign. The plus sign has 5 squares. Each has perimeter 24. The radius you have to find out. So each side is 24, meaning, sorry, each perimeter is 24 means these are all 4. Sorry, these are all 6. Now, if this is the center, that's our radius. If I drop the perpendicular here, so these are all 6, right? So that's 18. So half of that, this is 9. And we need to figure this out. So this is 3. So that means the radius would be square root of 9 squared plus 3 squared. So 81 plus 9 is 90. So that's 3 root 10. Or we can just keep it as root over of 90. So we are comparing root 90 versus 9. Squaring it, you have 90 versus 81. Clearly, 90 is bigger. So quantity A is the greater of them. Okay, so that is how we can figure out the radius of this shape. Next. So in this coordinate system, we have to figure out this AB and CD are given as 2 points. So there's very simple question actually. If you look at AB comma 0, 0, then the distance between the 2 points is root over A minus 0 squared plus B minus 0 squared, A squared plus B squared. And this is your root over C squared plus D squared. Both are radii. So that means the two are equal. So the answer is C. Okay. Next, this is on overlapping sets. So this one is saying that if you have some sets R, S, and T, they have the same number of elements. So you've got R, S, and T equal number of elements. The number of elements in RUT. So RUT would be R plus T minus R intersection T, which is like R or T is R plus T minus R and T. Similarly, SUT would be S plus T minus S intersection T. You're saying that RUT is less than SUT, so this is less. Now see, R and T, the sum, and S and T's sum, they are the same because they're given that they're equal sets, right? But after subtracting R and intersection T, it becomes smaller than after subtracting S intersection T. So that means what? This subtraction must be bigger. That's why this value has become smaller. So quantity A is bigger than quantity B. You subtracted a bigger number, only then you get a smaller value, right? Next, number 13, we have to find the area of this shaded region as a fraction of the total. And they're all midpoints, it's mentioned in the question. If they're midpoints, we can just pick them, let us say, since they're asking about the fraction, so we can just assume the length of the side of the square instead of taking variable. So we can, let's say, just take this is 2, this is 2, just for convenience. And now, since this is midpoint, and these two lines are going to be parallel, and so are these two going to be parallel. So we have similar triangles. This one similar to this. Okay. Now, since those two triangles are similar, if this is the midpoint, then this also should be the midpoint because the side ratios are constant. So that means if this length is x, then this is also x. But again, this length should be half of this. So as you can see, that this corresponds to this only, right? Because it's just the same diagram. All of these triangles are identical, just rotated. So that means this is also x. So we'll just first write down all of these which are x. Okay. These are all x. And these are all going to be half of x, x over 2. Right? So now we can solve this right angle triangle here, which is saying 2x squared plus x squared is 4 squared. So that means 5x squared is 16. So x squared is 16 over 5. So now the question is the shaded region, the area is x squared only, right? Is what fraction of the total? The total is 4 squared, 16. We want to find x squared by 16. So from here we can clearly say x squared by 16 therefore is 1/5. So that is the second option. So this is the proper way in which you can solve this. There's another way which you can look at this. Since this is the midpoint, if I were to just drop a perpendicular, you will create another triangle which is identical, right? And now if I draw this, so we have got 4 identical triangles here. So we can repeat that for all of them. We have another 4 and 4 more and 4 more. So already 16 triangles. And now if I just join the midpoint and do the same thing for this, another 4. So we have a total of 20 small triangles, out of which the middle square has only 4. So the ratio is 1/5. This is the faster way by observation. Okay. If you can observe that this is how it is working out, then it becomes very fast. All right, let's move on to our last question. So you've got 5 numbers in this list, and the median is greater than the average. It's given. So what's the median here? So let's arrange them. So 4, 5, 5, 8. So if x is here, so different possibilities. Then we also have another one. And finally, these are the 5 places where we can have x. So what is the average? So let's add them up. So 5, 5, 10, 18 plus 4, 22. So we have got 22 plus x divided by 5. That's the mean. And the median is greater than this. So here the median is 5. So that means we get x plus 22 is less than 25. So x is less than 3. Over here also the median is 5. So that we'll get the same result. Over here the median is x. But then between 5 and 5, and you're looking at an integer, right? I mean, between 5 and 5, you can't have anything else other than 5 itself, right? Not less, not more. So x itself is 5. And in that case, the median itself is 5 as well. So it's the same scenario. Here also the median is 5. And here also the median is 5. So that means in all of these cases, the median is actually 5. So we just have only one solution, that x is always less than 3. So quantity B is bigger, and that is our answer. So as you can see, the questions on the GRE are not extremely complicated or not too much in depth, except barring maybe one or two. Most of the questions have some logic or some twist in the question. So if you can spot that twist, then the question becomes easier to solve. So the focus should be on getting your concepts right, work on your concepts well, and then solve questions which test you on those skills so that you are aware of what all you can expect in the test. All right, thanks for watching.